Alright, so in this video, we are going to discuss about the relative stability of carbon radicals, carbocation and carbanion. Alright, so let's focus on the carbon radical first. So the carbon that got the unpaired electron here, we call it as a carbon radical. So the carbon radical, since it's only got one unpaired electron on this carbon, okay, it is an electron deficient species. That means the electron density on this carbon is relatively low. Since the electron density on this carbon is low, it will be stabilized by the presence of an alkyl group, which is an electron donating group. An alkyl group will donate the electron towards these carbon radicals to increase the electron density on this carbon. As the number of alkyl group increases, the stability of the carbon radical will also increases. Okay, so now let's have a look at the compound that we have here. So we have 4 carbon radicals. Okay, let's classify each of the carbon radicals first and identify how many alkyl group attached to it. For the first one, okay, so let's highlight the carbon radicals. Okay, so this is our carbon radicals, and then have a look at this carbon, how many carbon that attach to this carbon. So if you look at this structure carefully, okay, on this carbon there is only one carbon that attached to it. So this whole group, okay, we call it as an alkyl group. Okay, since there's only one carbon that attached to this carbon, this is a primary carbon radicals. For the second structure, this is our carbon radicals, and then we have 3 carbon that attach to this carbon, so we have 3 alkyl group attached to it. So this is our tertiary carbon radicals. For the third one, okay, for this carbon, there is no carbon attached to it, so this one actually is a methyl radical. Okay, and the last one, okay, we have 2 carbon attached to the carbon radicals, so 2 alkyls group. So this one is secondary carbon radicals. Since the question asks you to arrange the species in order of increasing stability, so you should arrange it, okay, from the lowest stability to the highest stability. So the methyl carbon radical here, okay, has the lowest stability, so we label it as A, okay, followed by primary carbon radicals because it's only got one alkyl group, so this one is our structure B, and then secondary C, tertiary D, and then to arrange it, okay, so A, B, C, D, and then put an arrow here and label it as increasing stability. And also in your answer, okay, state how many alkyl group attached to each structure. Right, so A, we have no alkyl group. Okay, for structure B, we have one alkyl group. C, we have two alkyl group. And then D, we have three alkyl group. Right, so that's why D will have the highest stability compared to C, B, and A because because as the number of alkyl group increases, stability of radical will also increases. B, we have positively charged of carbon. Okay, so this one is a carbocation. So carbocation is an electron deficient species, and same like our carbon radical just now, okay, it has a low electron density on this carbon. Thus, an alkyl group, which is an electron donating group, will stabilize this carbocation. As the number of alkyl group increases, the stability of carbocation will also increases. So let's have a look at our species here. For the first one, okay, this is our carbocation, and we only got one alkyl group attached to it because there's only one carbon that attached to this carbocation. For the second one, right, so we have 3 alkyl group attached to it. For the third one, no carbon attached to our carbocation. And then for the fourth species, we have 2 alkyl group attached to it. So again, this one is primary carbocation, tertiary carbocation, methyl carbocation, and also secondary carbocation. So as the question asks you to arrange it in order of increasing stability, the one that least stable is our methyl carbocation. So let's label it as A. And then we have primary, secondary, and the most stable is tertiary carbocation. And again, right, arrange it as A, B, C, and D. Alright, and then this is increasing stability, right? And then don't forget to mention how many alkyl group attached to our species.
Next species, we have a carbanion, which is carbon with negatively charged. So carbanion is an electron-rich species because it has a high electron density on that carbon. It will be destabilized by an alkyl group, which is an electron-donating group. As the number of alkyl group increases, the stability of our carbanion will decreases. So let's have a look at the first species. Okay, we have this carbanion. There's only one carbon atom attached to this carbon, so only one alkyl group present. This is a primary carbanion. The second one, we have 3 alkyl group attached to this carbon, so this is a tertiary carbanion. And the third one, there is no alkyl group present, so this is a methyl carbanion. And the last one, we have 2 alkyl group attached to it. So this one is a secondary carbanion. So since the methyl carbanion is have no alkyl group attached to it, so it is the most stable carbanion, but the tertiary carbanion is the least stable, so we label it as A, secondary B, primary C, and the methyl carbanion D. And then arrange it. Okay, we have A, B, C, D. Right, and then increasing stability, and then don't forget to label our species. Okay, label how many alkyl group present in each species. So that's it.